So good afternoon to all. So last class we discussed about the need of MMU, why there is a need of MMU, and during context switching in order to protect your memory, that is translation tables and all if we need to protect, and illegal access of the caches if we need to protect, some access permission should be given. So that is managed by using this MMU. So here what is this actually it's doing? So there are key services. One is it makes that as a reality that each process is running in their own memory space. It gives that virtuality. And then all are the design requirement of the individual task, what are the needs of the task has been simplified. It is provided by this MMU. And this virtual memory management. So how the physical memory is being translated from the virtual memory, all this conversion is being done by those MMU. So here the components of this MMU are they had a relocation registers and translation look aside buffer TLB, and domain and access permissions, caches and write buffer, and CP15 C1 control registers. So these are the major components which is present in this ARM MMU. So relocation register, that location registers, it will hold some content. What is that content is VMA, that is virtual memory address to physical memory address. For that conversion, what is the address is needed, so that will be holded by your relocation registers. And TLB, what TLB will be holding is it's actually a cache memory recent address translation, from which address to which address it has been translated, that the recent location will be loaded in the TLB. And coming to the block diagram, so this is how a virtual memory will work. So virtual memory having some task T1 starting from the region of 0x04, and it is the offset, the starting address is 0x04, and your task region is located at the region of E3. So that address that is actually a virtual address. So base address will be having and offset will be having. So what that MMU will do, that MMU, we know that MMU has one of the component called relocation register. So it will find out the equivalent physical memory address in the main memory. Okay, what is the address equivalent to your relocation, that is a virtual address. So that is provided by your MMU. So that translated address will be sent to the physical memory. Here the task, the origin task of your virtual memory is being located now in the address of 0x08 series. So this is how your virtual memory and your physical memory mapping is being done by using this MMU. So coming to your MMU component, we need that multiple relocation registers are possible. If you see here, there are many number of relocation registers are within your MMU. And TLB, we already discussed that TLB, what it is having is, it is actually a cache, a recent translation that will be stored in the TLB caches. And this page table entry. So what this page table entry will do is, the physical address used to translate the virtual page into physical page frame. So what this page table entry, it will have the physical address which is used to translate your virtual page into your page frame. So this translation has been done by the page table entry. And your access permission assigned to your page, because not all the pages are accessed, because the individual memory space is called as pages. So this is a one page, and here the individual space in your physical memory is called as page frame. Okay, and a cache and write buffer configuration for the page. So these and all will present in your page table. Okay, so again I just once again I will summarize. So multiple relocation registers. So we are having multiple relocation register inside your translation look aside buffer. And TLB caches, what it will be having is recent accessed pages. So from which virtual memory to which physical memory the recent translation happened, that we can able to see in the TLB caches. And each page table entry PTE will have the translation from virtual page to physical page frame, and what is the access permission, and the cache and write buffer configuration of the page. And coming to this MMU registers, here no need to discuss detailedly about the various each register format. That's just for understanding I have given like totally 0 to 15 registers are available. So here in that these things are unused, we are not using for any purpose, so remaining have its own function. And we know that primary function is used to translate the virtual address into physical address. This is one of the primary function. And second one, it controls the memory access permission aborting illegal access. So when illegal access will be happening is whenever it will ask for the memory which is not assigned for the particular range, then it is called as a illegal access. So that is controlled by this MMU. So this is mainly used for your context switching. This is mainly used for your context switching. So only we have discussed earlier, in context switching there we need an MMU, where the MMU is used in order to control your access permission. And already in the previous session we have discussed, when the processor has a separate instruction and data caches, it is likely to have a separate instruction and data translation look aside buffer. So we already know there are two types of caches are available, instruction cache and data cache. In a similar way, there is chances to have a separate instruction and data TLB, translation look aside buffer. And how the memories are being managed by this MMU mechanism, how the memory mapping is done is, either I can go for section, that is from virtual memory to physical memory, I can go for sections, large pages, small pages or tiny pages. A section is about 1 MB of memory, large pages is about 64 KB, small pages 4 KB, and tiny pages is about 1 KB. So all these things are memory ranges specified by your MMU. And domains. So what this domain is? Domain is a group of section or pages. Okay. So when this will come into picture is, if many processes are running at the same time with the same translation tables, but it will protect from each other. We already know this MMU will give a virtual environment that all the processes are running in the simultaneous manner, but they are independent to each other. In this way, domains, when they will come into picture is, when many processes are running at the same time and they are using the same translation tables, but it should not corrupt the other process. So they are giving some protection. So this protection is being done by this MMU. And it also provides much lightweight process switch. Suppose if they are using same translation tables, both the process P1 and P2 are using the same translation tables, that time switching mechanism, lightweight process switch mechanism is being enabled. So all these features are being used or incorporated in ARM because of this MMU architecture. And then two programs are written in order to provide a access control. So one is called as a client, the other one is called as a managers. So clients are nothing but the users of the domains. We already know in the previous slide, domain is a group of section or pages. So the users of the domain are called as clients. So they can observe the access permission of the individual sections and pages that make up to the domain. We can able to access the permission. This managers, who are the managers or the controllers of the domain? And they can bypass the access permission. They don't need any permission to use the individual pages or sections because they are the controllers. So access control is being done by two sort of programs: clients, the users of the domain, and the managers or the controllers of the domain. So by this way we are completing our MMU in ARM core. Thank you.